Welcome back. Today we will be talking about the sequence and series. Let's start with the difference between sequence and series. Sequence follows a pattern, whereas the series is a summation of the sequence. So order is important in the sequence, whereas there is no order. Order is not important in series. We talk about the finite and infinite with respect to the sequence and with respect to the series. So building on that, we have four types of sequence: arithmetic, geometric, harmonic, and Fibonacci numbers. So arithmetic talks about the common difference, whereas a common ratio will play the role for the geometric. In the harmonic, you can see the integers in the denominator, they follow the pattern. Fibonacci number, they are a recursive sequence, they are Fibonacci numbers. So each element is dependent on the two preceding numbers. Let's take the example here. So in this case, they are asking for the written expression for the nth term, that is n is the integer of the following sequence. So sequence, again, the pattern matters. So if you look at the denominator, they are in n terms. N is nothing but all the numbers, all the counted numbers, 1, 2, 3, and so on. In the numerator, we are starting with 2, but in the next term, we have 3. So there is a difference. What is the difference between 2 and 3? Difference is 1. Now from 3 to 4, we are talking about the numerator only. In the numerator, the difference is only 1. That means in the numerator, when n is equal to 1, numerator becomes n plus 1. When n is 2 in the second term, numerator will become n plus 1 again, right? So in the numerator, we are following n plus 1, but in the denominator, we have the term n. See, when the n was 3, the numerator was n plus 1, which is 4. So we identify the pattern in this particular question. Let's try one more. Now, in this case, again, we are considering n as the counting numbers. What will happen when n is 1? What will happen when n is 2? So if you look at the sequence that is given, they want when n is 1, the term should be 2. When n is 2, the term should be negative 5. So a n terms they are given. Now, here's the thing. I'm sorry about that. So when n is 2, if I say 2 squared plus 1, that gives me 5, right? If I try again, if the n is 1, then 1 squared plus 1, that is 2. That is my first term. If I follow the same pattern, if n is 3, then 3 squared plus 1, which is 10, that is my third term. So I know there is a pattern which talks about n squared plus 1. But there is also another pattern that talks about the negative number. Every alternative term is negative. So that means if I multiply negative 1 to the power of n plus 1, let's see what will happen. Negative 1, 1 plus 1 when n is 1. It is a positive number and my first term is positive, right? If I apply with the second term, negative 1 to the power of 2 plus 1, that gives you a negative 1 to the power of 3, which is a negative number. And you can see in this sequence, second term is negative. So if I combine these two patterns together, so we can come to the conclusion the pattern in this is negative 1 to the power of n plus 1 times n squared plus 1. So the first pattern, negative 1 to the power of n plus 1, will help you identify the positive and negative. Right? Now, what are recursive sequence? I talked about the Fibonacci numbers, they are recursive sequence. When the value of the term depends on one or more previous given terms. So in this particular case, we are given the first term, A1, and they have also given us the pattern, the formula to follow this recursive sequence. But the one thing that we need to keep in mind that all the values of n should be greater than or equal to 2. So we are not starting with 1. We are saying greater than or equal to 2. So the first 5 terms, that means when a is 1, let's use the formula and see if we are getting a1 as 3. We got a1 as 3. Now let's calculate a2. Following the same rule that is given, 2a and minus 1 plus 1. In this case, n is 2. So 2a, 2 minus 1 plus 1. What is a1? I got a1 as 3 in the previous case. So plug the value of a1 back. You will get 7. Now 7 is the value of A2, and I need that value to get the next term, which is 3. Remember, this is recursive, so every value is based on the previous values. So we got 2a squared, and what is a squared? A squared is 7. We just calculated it. So take the a squared away and plug the value of a2. It is not squared, a2. You will get 15. And similarly, you can calculate a4 and a5. Now, the another thing that will really help you when we dive deep into series is the factorial. So factorial, if n is a positive integer, that is very, very important. We are only talking about the positive integers. Then n factorial is defined as n factorial. What is the symbol of factorial? That is the exclamation sign that you use in English. 1 times, 2 times, 3 times, 4, all the way to n. But when we reach n, one term less than n, another term less than n. 1 factorial will be 1 and 0 factorial will also be 1. But why 0 factorial is 1? Because technically 0, there are no positive integer less than 0. So basically 0 factorial implies that it is an empty set without any number. Right? So remember the factorial positive integers, and we are multiplying all the number ascending to the particular number. For example, 3 factorial implies 1 times 2 times 3. Now 3n factorial. 3 is working as a constant, so kick the constant out. Times n factorial. What was n factorial? We discussed on the top. It is all the counting numbers 1, 2, 3, 4 multiplied together till n. That is n factorial. Right? If they talk about n plus 1, that means we talked about n factorial. They want n plus 1. So one more number, one more term will be added. That is called n plus 1. So factorials are quite easy, and they are fun to do because most of the times you can cancel out numerator and denominator. Now 6 factorial can be written as 4 factorial times 5 times 6, because 6 factorial is nothing but 1 times 2 times 3 times 4 times 5 times 6. And we have 4 factorial in the denominator. Cancel them out. What we are left with? 5 times 6 in the numerator and 2 in the denominator. Now 2 goes 3 times in 6. So what is left? Only 15. So whenever you are dealing with the factorial, try to cancel the numerator and denominator out instead of multiplying everything. Now, summation notation is very, very important, very crucial, because you need to study them again in calculus and in statistics. So summation is made up of the word sum. So sum implies when we are adding everything together, and when we add the terms together, that becomes series. So this is the symbol of summation. So this summation symbol constitute of various components. I is the index, 1 is the lower bound, n is the upper bound, and ai, that is the term that we are talking about. Remember, summation, add the terms of the sequence, so it is technically a series. Every single time you will not get the upper bound as n. It can be k, it can be I, or it can be any number. So let's take this example. We have a summation. I is the index, and the lower bound is 0. What is the upper bound? Upper bound is 8. And they are using the factorial in this case. So 1 over I factorial. So what they are trying to say, start plugging the value of I as 0 and go all the way to 8. It is a summation, so you are adding everything. So 1 over 0 factorial, 1 over 1 factorial, 1 over 2 factorial, 1 over 3 factorial, 1 over 4, and so on, all the way to 1 over 8 factorial. Previously, I said try to cancel out the numerator and denominator when dealing with the factorial, but in this case, I cannot cancel out because the numerator is 1. But remember, 0 factorial is 1, so the first two terms will be 1 plus 1. And when you simplify all of these factorials, you will get fractions, something like this. At this point, you need a calculator to get these fractions done. You will get approximately 7, 1, 8, 2, 8, and so on. And if you can recognize, this is nothing but E, Euler's number, right? Quite interesting, no? There are certain properties of summation that are quite useful and handy. For the first one, C is just a constant. So when a constant is there, there is no number, right? So the value will be C times N. That means C times the upper bound. In the second case, we have a term and the constant. So kick the constant out and then deal with the number. So if you remember in the previous example, we did 3n factorial. So 3 was the constant. If the two terms are added together under the summation, you can create two different summations. So with the help of summation symbol, we will be able to calculate series. So finite series, we talk about the partial sum. Finite series is nothing but the partial sum that helps us to calculate the infinite series. Let's take one example. And in this example, we will talk about both finite and infinite. So the summation symbol is there. N is equal to 1 to infinity. That means the lower bound is 1 and the upper bound is given as infinity. And the term is there. But in the first problem, they want us to change the upper bound from infinity to 3 because they said third partial sum. So whenever the word partial is there, that means they want you to change that infinity into that particular number. So if I plug the value of n as 1, 2, and 3, you will get a finite number as 0.333. So they want the third partial sum. Now let's calculate this without the partial sum in totality, what they want. So upper bound as infinity and lower bound as 1. So it is not possible to write all the numbers to infinity because we don't know the exact what is infinity. So infinity is unbounded, right? So if I continue this pattern, you will get 0.3 plus 0.03 and 0.003. So decimal will keep on shifting. And finally, we can get 0.333 repeating, which is nothing but a fraction of 1/3. So even though we were calculating the summation of infinite, we are getting a finite number. Quite interesting. Let's take one application problem. So the same thing can be the pattern of the sequence and the series can be used with the application problem. In this case, we are talking about there is an investment of 1,000. The function is given at 3% compounded annually. So the formula for compounded annually, everything is given to you. Again, we are talking about when n, that means 1, 2, 3, and so on. So in the first case, they are asking about the sequence. That means the terms. What is the value of A0, A1, A2, and A3? So we will use the same formula that is given in this problem and replace the value of n as 0, 1, and 2. You can use your calculator. For the A0, you don't need a calculator because anything to the power of 0 is just 1. And then A2 will be, use the same formula, you will get 1005.006. On the other hand, in part B, they are talking about by compounding 48th term. That implies they want you to put the value of n as 48. So what is 48? A48. So replace the value of n as 48. That will give you the balance after 4 years because we are talking about compounding continuously. This is the whole entire introduction. I hope it made sense, and I will see you next time.